So technically, like MACC requires 20%, but for the semester I'll just do 10%, and then for the people taking college credit, 2 10% finals average out at the end. So. Okay. Let's start looking at these. Bless you.
Thank you.
Problem 29. Equation of a line. Mrs. Keller would be so disappointed if I told her you guys didn't know this one. How many lines did you write the equations for in Algebra 1 and Algebra 2? Okay. So if we're going to write the equation of a line, you need a slope and a y-intercept. Right? We know a line is y equals mx plus b. So our final line, we have to have the m and we have to have the b. I told you it is perpendicular to this. So the parallel perpendicular tells you about the slope. What do we know about parallel lines? Parallel lines would be the same slope because they never meet. And if they're perpendicular, they are opposite reciprocals. Okay. Easiest way to find the slope of this line is to put it in y equals mx plus b form. And then m is your slope. So if I'm going to solve for y, I first subtract my 2x, divide everything by -5. I get y equals a 2/5 x minus 6/5. So right now the slope of this line is 2/5. Now if I said I wanted to be parallel to that, you would keep the 2/5, but I want to be perpendicular. So for my line, what slope am I going to use? So I need a slope with a line with a slope of -5/2. That is the only thing I use this for, so now just ignore it. You don't need anything else from that. The other thing we were given in the problem is it goes through the point 4, 1. So to write my equation, I need m and I need b. I have my m already. We have to find the b. So we're going to take this stuff and plug into y equals mx plus b. Y is 1, m -5/2, x is 4, plus b. Add your 10 over, and b is 11. So I have m, I have b, so that is my final equation. Y equals -5/2 x plus 11. Does that make sense to everybody? I know it's been a little while since we did those lines. Okay, problem 32. Wants the distance. So I did tell you yesterday I would give you the distance formula on the final. You don't have to memorize it, you just have to be able to use it. So we have the points -7, 4, and 3, -2. So this is like x sub 1, y sub 1, x sub 2, and y sub 2. So if I plug those in, x sub 2 would be 3 minus -7 squared plus y sub 2 is -2 minus 4 squared. 3 minus negative, so 3 plus 7 is 10. 10 squared is 100. This would be -6 squared is positive 36. So I get the square root of 136. Can I leave my answer like that? No. You have to pull out any perfect squares if you can. So you first check, 136 is not a perfect square, so that doesn't reduce, but it is divisible by 4. So you could separate it into a 4 and what? 30 what? So then the square root of 4 is a 2, and we have the square root of 34 remaining. Double check, that's only divisible by 2 and 17, which are both prime numbers. They don't break down. So that is our final answer. I want it in radical form, not decimal. Sound okay? Number 33. Okay, so the first thing I asked for on part A was g composed with f. That means g of f of x. So you start on the inside. That's x squared minus 3x minus 4. And I have to plug that into g. So g is 1 over x, so you replace your x with the x squared minus 3x minus 4. That's part A. Part B wants the domain of this composition. So when you do the domains of a composition, you look 2 places. You look at the original thing you plugged in, and you look at your final answer. Now this original thing I plugged in, is there anything x can't be? Well, here, it could really be anything, couldn't it? Because we look for fractions and square roots. If we have a fraction, the bottom can't be 0. If we have a square root, then whatever's underneath has to be positive. So there's no fraction, no square root. There's nothing of concern here. But at the end, I end with a fraction. And we know that if it's a fraction, the denominator can't be 0. So that means x squared minus 3x minus 4 cannot equal 0. Right? It's a quadratic. We can do box method. So x squared breaks into x. Multiplied to negative 4, add to negative 3 would be a negative 4 and a positive 1. Set each of those to 0 and you get positive 4 and negative 1. If it's more than one value that x can't equal, I let you just list them. So x can't be either of those things because both give you 0 on the bottom of the fraction. Any questions about that? Okay, make sure you're correcting this if you missed it. 35. Okay, so I am just asking you to solve this inequality. It only has an x to the first, so it's linear, so we're just going to get x by itself. So we start by distributing, so that's 15 minus 5x. If I want all my x's on the same side, I'm going to add over my 5x. And I'll subtract this 3. Divide by 4, we get x is greater than or equal to 3. If I asked for the interval notation, which I probably would on your final, this is everything larger than 3. Equal to means brackets, so it'd be 3 comma infinity. (37) is another linear inequality. It's kind of like question number 20 that we talked about yesterday. It looks scary because of the fractions, But this is something we can solve. You've got a calculator if you get hung up on your fractions. X over 7 is the same as 1/7 x minus 3. If I separate this would be x over 3, so 1/3 x, minus 4 over 3, plus 1. So if I add these like terms, negative 4/3 and positive 1, will give me a negative 1/3. We need all of our x's on one side, so I'm going to subtract over this 1/3 x. So this is where if you need to pull out your calculator, you can. Just make sure you put parentheses around both. So 1/7 minus 1/3, I believe is negative 4 over 21. Add your 3 to the other side. So negative 1/3 plus 3 would be an 8/3. Then how do we finish here? Okay, multiply by the reciprocal, which would be a negative 21 over 4. What happens if you multiply or divide by a negative in an inequality? It flips. So now it's x is less than negative 14. Again, if you're doing those in your calculator, put each fraction in parentheses so it works out. So this says everything's smaller than negative 14, so it would be negative infinity, comma, negative 14, and it gets a parenthesis because it's not equal to. Is that one okay? Problem 40 is another linear inequality. It's just a compound one. Okay, so on this compound, whatever you do to the center, you have to do to both ends. I want to get x by itself, so what would be the first thing here? Multiply by negative 6. If you multiply by a negative, what happens to all of the inequalities? They flip. So we get negative 48 is greater than, in the middle those negative 6 drop, and just give you 3x minus 4. It's greater than negative 66. So now to get x by itself, what do? Alright, so you add 4 to everything. So we get negative 44 greater than 3x greater than negative 62. Then what do? Divide by 3. Do I have to flip my inequality? Non-negative, so no flips. Okay, so that's negative 44 over 3 is greater than x greater than negative 62 over 3. Alright. If you think about these in decimal form, so negative 44 over 3 turns out to be negative 14.6 repeating. Negative 62 over 3 is negative 20.6. So what it tells me, x is smaller than the negative 44 over 3. So that's going this way. And it's bigger than the negative 62 over 3. So it's going that way. Okay, if you flip those two numbers, it flips the inequalities, and then that's a little more how we're used to seeing the inequalities written. So my interval notation, you always put the smaller number first. It wasn't equal to, so parentheses, so negative 62 over 3, comma, negative 44 over 3. Anything else in that chunk that we haven't talked about but you needed to? Really, anything on the entire study guide that I have not yet covered that you want me to? Yes.
We could just do just a regular word problem.
Yes, you guys want a word problem? Alright, so I'm going to make up one. I would like for you guys to try it before we talk about it. I'll just give you a couple minutes to see if you can set it up before I start going over it. And if you would, you can just do this on a separate sheet of paper. So I already told you yesterday that I'm probably going to give you an interest one. Let's see. Okay, let's do... You have $75,000. Ellen will invest some at, let's say, 8% and some at 9% interest to earn $6,550 after 1 year. How much should be invested at each amount? So set this up for me. So that's your first problem. Okay, we ready to go over that one? Okay, so how do you have to begin here? What do we need to draw? Make a table. Okay, it's an interest one, which is what I told you we'll have on the final, so principal times rate times time equals interest. Okay, so you are investing some of this at 8% and some of it at 9%, and then we just have our total. You have $75,000. Where do you put that? Total principal. So what would you put for your amount at 8%? Then what does that leave for 9%? Okay, your rate. 8% would be 0.08, 9%, 0.09. Did I give you the percent for the overall? Nope, so we're just going to leave it blank. I said after 1 year, so my time is just 1. So interest, you multiply. X times 0.08 times 1, so 0.08x. That's when we multiply across, so we get 0.09 times 75,000 minus x. And what is my total interest? $6,550. Okay, so what do I need to do? Add the first two to equal your total. Okay, so if we work this out, okay. Combine like terms, so that's a negative 0.01x. If you subtract the 6750 over, equals a negative 200. Divide, and you get 20,000. So you need $20,000 at X was my 8%, and 75,000 minus 20,000 is 55,000 at 9%. Is that one okay with everybody? I'm trying to just go through and maybe hit some of the things that I know you guys have asked about and had trouble with that are definitely going to be on our final. So I just wrote down a few more problems. Is that all right? Okay. The multiplication and division, as well as the addition and subtraction, I know we kind of struggled with, so I thought maybe we should review some of that. You guys, why don't you take a minute and try a few of these problems. Okay, so just start with the first one. Work as far as you can in the next few minutes. So, to divide fractions, we have to flip and multiply. The first one stays the same. Change it to times, and you flip the second one. Okay, then our goal is to cancel things out as much as we can. So we're going to factor each of these pieces. So multiply -3 and add to +2. Okay, x squared minus 16, how does that factor? Okay, this one, multiply to 4 and add to 5. Okay, bottom. Multiply to 3 and add to 4. And then anything that's on both the top and the bottom cancels out. So I can drop out an x plus 3. I can drop out an x plus 4. And those x plus 1s cancel. So then you just multiply across with what's left. So all we have is an x minus 1 over an x minus 4. Second question. I asked you to subtract. If I want you to add or subtract, what do you have to have? Common denominator. Okay, the first thing I would do here, I recommend changing this minus to plus and then just making that a negative 3x. So my first denominator is x minus 2. In order to match the second one, what does it need? X plus 4. So you're going to multiply that on top and bottom. Okay, this one has the x plus 4, so it needs x minus 2. So if you multiply that, if we distribute, we get x squared plus 4x over x minus 2, x plus 4, plus distribute my negative 3x, so negative 3x squared plus 6x over x minus 2 and x plus 4. If your denominators are the same, you can put these together into one big fraction. Add the tops. So 1x squared and negative 3x squared, negative 2x squared. 4x plus 6x is 10x. You don't have to factor that, you're just leaving it. So that is our final answer. So you have to be able to get that common denominator. Is that one okay? Let's do another. We didn't go over any of these today. They were on your last test, those quadratic inequalities. Let's do one of those. So if I said x squared minus 5x minus 6 is greater than 0, where do you have to start? Factor it. So it's a 1x squared, we can do the shortcut. Multiply a negative 6 and add to negative 5. Okay. From here, we figured out what made each of those equal 0. So what makes x minus 6 equal 0? Positive 6 and x plus 1. Alright, so we thought about those on a graph. Did the original quadratic open up or down? Opens up. I asked where this was greater than 0. Greater than means above the axis. So it's above the axis in this section and this section. So if we write our intervals, this is coming from negative infinity to negative 1. Gets a parenthesis because it's not equal to union 6 to infinity.
What does the union do again?
It's just saying or. It's this piece or that piece. Is that one okay? Let's do another equation of the line. So I want the equation of the line going through the point negative 3, 4 and perpendicular to this line. Good. Start by finding the slope of that line. So if I want y equals mx plus b, subtract over our 2x, and then divide everything by -3. So we get y equals a positive 2/3 x minus 5/3. So the slope of this line right now is positive 2/3. If you want to be perpendicular, what do you do to your slope? So be at -3/2. This is a positive. Sorry, I just have a stray mark right there. That's a positive 2/3. So flip it and make it negative. That is all I needed this line for. So just ignore it now. The other piece of information I told you was that it goes through the point -3, 4. So now I have a point and slope. We plug into y equals mx plus b. So our y is 4, m -3/2, x is -3 plus b. Subtract over that 9/2, and we get -1/2 for our b. So the final equation then is y equals our slope, -3/2 x minus 1/2. Is that okay? Do you guys have something specific, or you want me to just keep making up some problems? I'm the one that wrote the final, so you guys are okay with me making up the review problems? Let's see. Let's find f composed with g if f of x is -3/x minus 2 and g of x is 4x plus 1. Okay, what does that mean? Yep. F composed with g means f of g of x. So you are going to take your g and plug it into f. You're replacing that x. So we have a -3 over, if I put in g, that's 4x plus 1. And then we still have that -2. Is that as far as I can go? No, go ahead and combine the like terms. So you get -3 over 4x minus 1. Okay, what if I said give the domain? So what we have to worry about are fractions and radicals. Do we have any radicals in this problem? No. Do I have a fraction? Yes. So if you have a fraction, what do you know can't happen? The bottom can't be 0. So 4x minus 1 cannot equal 0. Add over your 1, divide by 4. X can't be 1/4. How would I write that as an interval? So everything except 1/4, so it would be -infinity to positive 1/4 union 1/4 to infinity. So be prepared to write that interval notation. Let's do Okay, we did a lot of the absolute value equations yesterday. We worked out several of those. There was one absolute value inequality on today's section. You didn't ask about it, but let's go over one. So when it's an absolute value inequality, it's like I ask you, is this an and or an or statement? Remember, less than is an and, so greater than is an or. So this would be or. So with or, you do two separate inequalities. The first one, all you do is drop the absolute value. The second one, what do? You make it a -5, and what do you do with the inequality? Flip it. Now, if this were an equal to, you would just say equals +5 equals -5. With the inequality, you flip the second one. So then we solve each of these. Divide by 3, so x is greater than 2. Over here, if we add our 1, divide x is less than -4/3. And how would I like for you to write this? Yep, interval notation. So less than -4/3 is -4/3, sorry, -infinity to -4/3. Greater than 2 is 2 to infinity. Is that okay? What if I ask you to graph a piecewise? How do you do that? How many T-charts do I need here? 2, one for each piece. Okay, so for the first one, what number do I plug in first? 0, and then I need things greater. Okay, so if I put in 0, 0 minus 5 is -5. If I put in 1, I get -2. If I put in 2, we get 1. Open or closed at 0? Closed because of the equal to. Then I've got 1, -2, 2, 1. So it goes this way. Second piece, what do we have to plug in first? Will it be open or closed? Open, because it doesn't have an equal to. Then we need things less than that. So maybe a -1 and a -2. So -2 times 0, 0. -2 times -1 is 2. -2 times -2 is 4. So 0, 0 is open. -1, 2. -2, 4. And it extends that way. Okay, so tomorrow, bring your study guide. You're turning that in. If you don't do anything else to study, I would probably at least rewatch this portion of the video where we just did the extra review and kind of hit, because these are some of the things that I know we've talked about, you had a little more trouble with, and they're definitely included on your final. So I will post this on the YouTube page now. Are there